reverse it. And that would be your north, this would be your north end, this would be your south end on this particular thing. Now, coils behave exactly like magnets. They have a more or less a north end and a south end. And as far as I know, this has never been published in the English language. This was actually a Russian publication in Romanian from back in the 30s. And we're going to see how that ties together with some of the other things. Okay, this is can you see that okay? What I've done there, I've taken the Tesla coil with the center tap on it, and I've shown what actually happens when electrons move in one direction. The amperage part goes the other way. As it turns out, there's two types of electrons. There's one that's a little bit smaller and weaker than the other, and it becomes when it spins its direction, it becomes the amperage part, and the stronger of the two electrons spins and makes the voltage part. And in nature, they are coupled together, and that's the reason why they're inactive and floating about in space without anything happening. It's whenever you disturb them or knock them apart that they try to get back together, and that's where you get your useful energy. And they're relatively easy to disturb. You can do it either by electromagnetic methods, or you can do it with the conventional coils and magnet system, which is also electromagnetic. But it's much easier, much more efficient, and the rate of disturbance determines the amount of energy that you end up with, which means that 60 cycles, generating at 60 cycles, you're wasting your time. If you're generating, the amount of energy output is directly related to the square of the cycles per second. So at 60 cycles, square that, then square 218 million times a second, and you will see that the efficiency on my device has gone up unbelievably. As a matter of fact, it's gone on the chart, it's gone straight out of the sky. And these electrons, when you disturb them, they are not in any way diminished. They simply will go back to their normal habits the first chance they get, and they will be there, and you can use them over and over again. You're not disturbing the environment or doing anything which is harmful to human beings, depending on the frequency you're running at. If you're down in the lower frequencies, say down below the radio frequency, which is below 20,000, the lower you go, the more harmful the environmental effects are from electricity. The frequency that was chosen to be the standard was probably the worst possible frequency imaginable. A better version of it is the 400 cycles per second, or actually it's 400 up and 400 down, which is 800, which would be considerably more efficient and better than the 60 cycle way of going. And we see it in the electrical vehicles and the wiring systems in the airplanes and the servo mechanisms for controlling the airplanes, the wheels and all parts of it, including a lot of the service vehicles that they use at the airport. They're running at 400 cycles a second, which means they're running at a higher voltage. They're running like 440 at 400 cycles, and the lower the cycles, the more the heat and the wasting of the energy. So the higher the cycles you run at, the less harm to human beings, the environment, and other things, and the greater the efficiency. So as you go into the higher frequencies, it's real easy to trip over into the over-unity systems which we're seeing here today. This illustration is in the current issue of the Tesla magazine, which they have some copies in the bookshop in case you want to look closer at it. The electron is a very useful thing. It produces a number of things which we normally don't think about. As you can see there, we have two basic types of related energy. We have the resistance or the impact and the light, the heat deal, and then we have the electromagnetic reaction, which is up at the top. There's methods of storing this energy without disturbing or destroying the electrons. And the whole idea behind how this thing works hinges around the fact that you can take the energy without diminishing the electrons. Okay, the basic storage formulas are these. And you'll notice that part of the formula gets squared. And this takes you directly back to EMC squared, or the things that led up to what Einstein later put into a statement which he gets credited for. The idea had been around quite a long time. As a matter of fact, if you go back to Maxwell and the people that were working early on, or sort of, not real early, but sort of early on, their ideas about electricity are almost identical to what I have. In reading the early accounts, Maxwell would have no trouble at all agreeing with everything that I've been saying. He doesn't agree with what is taught in the physics books here. They quote Maxwell all the time, but they only quote him out of text, and they quote him in such a way that he's saying something which he would not have said if he was personally, physically present. And how do I know that? I've been reading the documentation done by the people that actually worked with Maxwell and some of his actual writings. The book that you see that's accredited to Maxwell was not written by Maxwell. And he probably would have had some difficulty with it. Now that we know that those formulas exist, let's see what they really can do. Okay, a joule, a watt second, coulomb, a farad, all those things are 1 volt at 1 amp at basically 1 second. They're all the same thing. They're used in different statements and ways that appear to make them be different, but really they basically